We are going to learn about the unit circle. And before I continue, I just want to say that this video is for understanding the unit circle. This is not to help you memorize the unit circle before a test. The unit circle is such a fun and interesting topic because there are so many ways to think about it and there are so many applications of it. It is one of the foundations for pre-calculus and calculus. So I'm going to draw the coordinate plane here. And the unit circle is a circle, so I will draw a circle here as well. Now, it's called a unit circle because the radius of the circle is 1. So that means this length is 1, this length is 1, this length is 1, and this length is 1. And remember, a radius is a straight line from the center of the circle to the surface of the circle. So in that case, this is also the radius, and since it is the unit circle, this radius is 1. This is also the radius since it is a straight line from the center of the circle to the surface of the circle. This is also the radius. 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 This is the radius, this is the radius, this is the radius, and this is the radius, and this is the radius, and this is also the radius. The plural of radius is radii, so all the radii I drew are equal to 1. Since it is the unit circle, and by definition, the unit circle has a radius of 1. So I'm going to divide the unit circle into 8 pie slices. We are going to focus just on the bolded lines for now. So this line's angle is 0, and this line's angle is going to be pi over 4. This line's angle you can think of as 2 pi over 4, which is reduced to pi over 2. This line's angle is 3 pi over 4, and this one is 4 pi over 4, which is reduced to pi. This angle is 5 pi over 4. This angle is 6 pi over 4, which is reduced to 3 pi over 2. And this angle is 7 pi over 4. Then the last line, which we wrote as 0, is also known as 8 pi over 4, which can be reduced even further to 2 pi. Now, we are going to look at the other angles that we didn't fill in. The first one is pi over 6. This one is 2 pi over 6, which is reduced to pi over 3. This one is 3 pi over 6, which we figured out is pi over 2. This one is 4 pi over 6, which is reduced to 2 pi over 3. This one is 5 pi over 6. This one is 6 pi over 6, which is reduced to pi. This one is 7 pi over 6. This one is 8 pi over 6, which can be reduced to 4 pi over 3. This one is 9 pi over 6, which is reduced to 3 pi over 2, which we already have. This one is 10 pi over 6, which is reduced to 5 pi over 3. This one is 11 pi over 6. And this one is 12 pi over 6, which is reduced to 2 pi, which we already have. Essentially, all you need to memorize is that this is pi over 6 and that this is pi over 4, and you can derive the other angles. Now, what does pi over 6, pi over 4, pi over 3, and so on and so forth mean? These are radians. So how do we convert them to degrees? One very important thing to know is that pi equals 180 degrees. So if we substitute 180 for pi in each of these radians, then we can find the degrees of the angles, and the degrees of the angles might make more sense to you. So pi equals 180 degrees. If we look at pi over 6, we will substitute 180 for pi. So we will get 180 divided by 6, which is equal to 30 degrees. Now, we will look at pi over 4. We will substitute 180 for pi and get 180 divided by 4 equals 45. So this whole angle is 45 degrees. Now, we will look at pi over 3. We will substitute 180 for pi and we'll get 180 divided by 3 equals 60. Therefore, this whole angle is 60 degrees. Now, we will look at pi over 2. 180 divided by 2 is 90 degrees. So this angle is 90 degrees. 2 pi over 3 equals 2 times 180 divided by 3, which equals 360 divided by 3, which equals 120. Therefore, 2 pi over 3 equals 120 degrees. This whole angle is 120 degrees. Now we will look at 3 pi over 4. 3 times 180 divided by 4 equals 540 over 4, which equals 135 degrees. 5 pi over 6 equals 5 times 180 divided by 6, which equals 150 degrees. Pi equals 180 degrees, so this whole angle is 180 degrees. 7 pi over 6 equals 7 times 180 divided by 6, which equals 210 degrees. 5 pi over 4 equals 5 times 180 divided by 4, which equals 225 degrees. So this whole angle is 225 degrees. 4 pi over 3 is 4 times 180 divided by 3, which is 240 degrees. 3 pi over 2 equals 3 times 180 divided by 2, which equals 270 degrees. So this whole angle is 270 degrees. 5 pi over 3 equals 5 times 180 divided by 3, which equals 300 degrees. 7 pi over 4 equals 7 times 180 divided by 4, which equals 315 degrees. 11 pi over 6 equals 11 times 180 divided by 6, which equals 330 degrees. And 2 pi equals 2 times 180, which equals 360 degrees. And this makes sense because the angle of a circle is 360 degrees. Now I want to clarify that this video is to understand the unit circle, not to memorize it. This is to understand why things are what they are in the unit circle. Now, let's look at the coordinates for each angle. And let's start off with 0 or 2 pi. Let's look at what its coordinates are. Since it is a unit circle with a radius of 1, and this line is the radius, the coordinates are 1, 0. So let's look at pi over 2. Since this is the radius, and the radius is 1, the coordinates for pi over 2 are 1, 0. Let's look at pi. The coordinates are -1, 0. And finally, let's look at 3 pi over 2. The radius is 1, and since this is the radius, the coordinates are 0, -1. Now, let's move on to something different. Let's look at pi over 6, hence 30 degrees. Let's look at this 30-degree line. And I'm going to draw it here since it is a bit messy over there. So I'm going to draw this pi slice over here of pi over 6. And if I draw a vertical line from here to here, you can see that we made a triangle. And over here, since we drew a straight vertical line, this angle is 90 degrees. And we reviewed that this is pi over 6, which equals 30 degrees. So there is a 30-degree angle over here. And we know that since it is a unit circle, its radius is 1. So on this drawing, the hypotenuse is 1. So I'm going to redraw this with just the triangle. Now, to understand this part of the video, you will need to be familiar with special right triangles, meaning you will need to be familiar with 30, 60, 90 triangles and 45, 45, 90 triangles. If you are not familiar with those, please look at the video linked below on special right triangles. So all angles of a triangle add up to 180 degrees. Since this angle is 30 degrees and this angle is 90 degrees, this angle is 60 degrees. 30 plus 60 plus 90 adds up to 180 degrees, which is how many degrees a triangle should have. So over here we have a 30, 60, 90 triangle. This is a special triangle. So if you recall from 30, 60, 90 triangles, 30, 60, 90 triangles have a ratio of x to x root 3 to 2x. X is the shorter leg, x root 3 is the longer leg, and 2x is the hypotenuse. And we know that the shorter leg is always opposite the 30-degree angle, and the longer leg is always opposite the 60-degree angle. Again, if this sounds completely new to you, please look at the video for special right triangles. So let's see what we are given. We are given just the hypotenuse, which we know is 1, since it is a unit circle. So we have the ratio x to x root 3 to 2x, and we have some number to 1. So we are going to find out what both these numbers are. Hence, we are going to find what all 3 sides of the triangle are. So let's look at the shorter leg and the hypotenuse first. So the ratio is going to be x to 2x and some number to 1. So we set the two hypotenuses equal to each other. So we have 2x equals 1. And we get x equals 1 over 2. Therefore, the shorter leg is 1 over 2. So I will label this 1 over 2 on the triangle. The shorter leg is opposite the 30-degree angle, so 1/2 is this side length. Now, let's find the longer leg. And the longer leg is x root 3. So we know that x equals 1/2 in the context of pi over 6. Therefore, the longer leg is 1 over 2 times root 3, which is equal to root 3 over 2. Therefore, the longer leg, which is opposite the 60-degree angle, is root 3 over 2. And it will be here on the triangle. So we have the side lengths root 3 over 2 and 1/2. Another way to think about this is that you are going across root 3 over 2 units and are going up 1 over 2 units. Therefore, the coordinates for the pi over 6 angle are root 3 over 2, comma 1/2. Root 3 over 2 is the x value and 1/2 is the y value. And the coordinates for pi over 6 are going to be the same for all radians that have a denominator of 6, except the signs are changed. So for 5 pi over 6, the coordinates are going to be negative root 3 over 2, comma 1/2, because 5 pi over 6 is in the second quadrant, where the x values are negative. 7 pi over 6 is going to have the coordinates negative root 3 over 2, comma negative 1/2, since 7 pi over 6 is in the third quadrant, where the x and y values are negative. 11 pi over 6 is going to have the coordinates root 3 over 2, comma negative 1/2, since the y value is negative. All the radians with the denominator of 6 have the same coordinate values, but the signs are different. So let's look at pi over 4. And pi over 4 we figured out was 45 degrees. So I will draw pi over 4 over here. So this is pi over 4, and we figured out this angle was 45 degrees. Now, if I draw a vertical line from here to here, this angle is going to be 90 degrees. All angles in a triangle have to add up to 180 degrees. Therefore, this angle is 45 degrees. 45 plus 45 plus 90 equals 180, and all triangles have to add up to 180 degrees. We now have a 45-45-90 triangle. This is a special triangle. And we know the radius is 1, and therefore the hypotenuse in this triangle is 1. So, the ratio for the side lengths in a 45-45-90 triangle are x to x to x root 2. The two x's are the legs, and x root 2 is the hypotenuse. So in this case, we have some number to 1. So we need to figure out the two legs. So I will look at just this part. X to x root 2 and some number to 1. I will set the two hypotenuses equal to each other so that we get x root 2 equals 1. Then I will divide both sides by root 2 to isolate x, and we will get x equals 1 over root 2. Now, we need to rationalize the denominator. If you do not know what rationalizing the denominator means, please watch the video on rationalizing the denominator without conjugates, which is linked below. We will multiply the numerator and denominator by root 2. We will get x equals root 2 over 2. Therefore, both the legs in this triangle equal root 2 over 2. So this side length equals root 2 over 2, and this side length equals root 2 over 2. Therefore, the coordinates for the pi over 4 angle are root 2 over 2, comma root 2 over 2. And the coordinates for pi over 4 are going to be the same for all radians that have a denominator of 4, except that the signs are changed. So, for 3 pi over 4, the coordinates are going to be negative root 2 over 2, comma root 2 over 2. Since 3 pi over 4 is in the second quadrant, where the x values are negative. For 5 pi over 4, the coordinates are going to be negative root 2 over 2, comma negative root 2 over 2, since 5 pi over 4 is in the third quadrant, where the x and y values are negative. For 7 pi over 4, the coordinates are going to be root 2 over 2, comma negative root 2 over 2, since the y values are negative in this quadrant. Now, let's look at pi over 3. And I'm going to draw pi over 3 over here. We reviewed pi over 3 equals 60 degrees, so this angle will be 60 degrees. And if I draw a vertical line from here to here, this angle is going to be 90 degrees. Therefore, this angle must be 30 degrees, since 30 plus 60 plus 90 equals 180 degrees, and a triangle must have 180 degrees. So this is another 30, 60, 90 triangle. So we can do all the work that we did, again, with solving for what the shorter leg or the longer leg is. Or we can look at the similarities between the pi over 6 triangle and the pi over 3 triangle. In the pi over 6 triangle, we got the ratio of the sides were 1/2 to root 3 over 2 to 1, where 1/2 was the side opposite to the 30-degree angle, root 3 over 2 was the side opposite the 60-degree angle, and 1 was the hypotenuse. This is the same thing for pi over 3, except the order is different. Since the 60 degrees over here, the side opposite it is root 3 over 2. And since the 30 degrees is over here, the side opposite it is 1/2. We can think of this as going 1/2 units across and root 3 over 2 units up. Therefore, the coordinates for pi over 3 are 1/2, comma root 3 over 2. 1/2 is the x value and root 3 over 2 is the y value. And the coordinates for pi over 3 are going to be the same for all radians that have a denominator of 3, except the signs are changed. So for 2 pi over 3, the coordinates are going to be negative 1/2 comma root 3 over 2. Since 2 pi over 3 is in the second quadrant where the x values are negative. The coordinates for 4 pi over 3 are going to be negative 1/2 comma negative root 3 over 2. Since 4 pi over 3 is in the third quadrant where the x and y values are negative. The coordinates for 5 pi over 3 are going to be 1/2 comma negative root 3 over 2. Since 5 pi over 3 is in the fourth quadrant, where the y value is negative.